itself yet, although someday perhaps it will. So I had the pleasure of working on Stout Street, which was an incredible project with quite a large team, and I'll go through that. Let's get this to work. All right, so just to get us kind of grounded on where the building is, I'm hoping that everyone is familiar with this. I think the original title was the most iconic building in Wellington. I think that got yanked because somebody thought maybe it wasn't the most iconic. But it's certainly quite iconic. I think it was it Gliding On? It was in the credits, I think it was. Ian's seen that, that's good. So this building is right across from the train, it's just down the street from the train station, and on Stout Street, obviously. And it's the old New Zealand Defence Force headquarters. So it was built in the 40s. Right now it's tenanted by MB, and the owners are Argosy Property Management Limited. It's about 20,000 square meters. So that 20,000 square meters is the Green Star net lettable area square meters. There's different numbers for gross and all this stuff. So it doesn't count things like elevator lobbies or toilets or shower areas. So it's maybe a smaller number than you might use on a lease document perhaps. But it's the number you use for all of your areas. Just like Julie was talking about how on Homestar that square meters of the building actually is very important. Well, in Green Star, that number right there is the most important number because everything gets divided by it. So that's how it. Say again?
Most important number, you're right.
And that was a good point. So the rating is a 5-star built rating. The design team, with some prodding, just targeted just a built rating and didn't get a design rating first. So yeah, it was a bit of a swear. Yes, it was a bit of a ballsy move, as it were. But it saved the cost of buying 2 ratings. Simple enough. And the team felt it was good. We had, in the end, we had sufficient points where it wasn't terribly stressful at the end. Paperwork's always fun, anyways. All right. I'd prefer this to be interactive, so please ask questions along the way. Break that rule. I'd much prefer to just. Yeah, I can handle finishing on time. It's not a problem. Okay, so I said we had a fairly large team. The project was a design-build project. I have difficulty imagining that we would have been successful with just a design, then bid, then build project. But that's just how it was run. So on our team, we had the owner, tenant representative was in all the design meetings. Once the tenant came on board, and this team. So this order of this list is roughly the order if I remember them coming on and helping out with Green Star. So it's not necessarily any other order other than this is when I remember meeting the people. So it's quite interesting that Acoustic was kind of the last people on board. So it's interesting. After the tenant even. But we had quite a good building. This is a building. This is a picture of the building from 1945-ish kind of time frame, as you can tell from the cars. So it's a bit of an old thing. And that's it. All right. So it's a heritage building. So it's finished in 1939. The building itself caused both good and bad things with Green Star, right? So on the good side, it had incredibly good fundamentals. It had really good shape. So initially it was an H with a big back light well. With the building was that back there, the brick building. Wellesley, thank you. Wellesley behind it, where the light well was back there. So that light well was filled in half with floor plate for additional floor space inside the building, and half became the 8-story atrium that's inside the building. The coffee shop's open, so if you want to get a coffee there, tell them I sent you, maybe I'll get a free one. And so the structure of the building, as we'll talk about in a little bit, was very sound. It meets current earthquake code ratings. The facade is a double skin facade. By that I mean it's just like a British double width brick. You've got an exterior stone layer, an air gap, and an interior structural cement steel core. So that meant you've got an air gap in the wall, so it's not just like a typical 1940s building, which might be solid brick or solid concrete. So it's quite a bit more insulating. And it had really good glazing ratio. If you look at just the walls on the finished building, we're something like 27% glazing ratio on the walls, which is pretty good. A modern building has much more window area. Since the windows tend to suck compared to the opaque walls, your energy consumption goes up. All right, so the design team purposely, in some cases, actually in almost all cases, improved those fundamentals. So the shape got better, it got more square. Just like you were saying, a cube's the best shape, right? Well, except for sphere. So the building got much more like a square. It went from an H shape to essentially a short U. So this front facade stayed dead in, but the back light well was completely filled in. And also because we're in Wellington in a business area, we bump up against other buildings that are conditioned. So essentially we turned ourselves into a row house by and putting that backlight well. So it removed all that area that you would lose heat. Now Wellesley Building's paying for their side of the wall, and you're paying for your side of the wall, and there's no heat loss between the buildings. Is how you model it. The new facade that was added was insulated. The new windows we added were all very high performance windows. The atrium windows were spectrally selective glazings, which caused me some, it didn't heat as well in the winter time, but it saved on cooling in the summertime. So it's pretty much a one-for-one trade in terms of energy. But it meant that the cooling plant could be smaller, which I like. The new windows in level 8 were all low E. They're not argon filled, but they are low E double glazed at least. And there was a few issues because it's heritage. Because it's a heritage facade, we've got bronze single panes windows. Like all these windows here are the original windows. They're still the original windows. So they're still single pane bronze windows. There were copper gutters up on the roof, and some of the downspouts were also, so we couldn't target emission credit that I would have liked to target because we had those metal ions in our runoff, essentially. But then again, there was enough flexibility tool that we could, for example, here's the digital bike rack. Technically, it's supposed to be under cover. The heritage guys didn't like the idea of putting a big class cover area out in front of the building, so we're able to go ahead and run CIR to get that waived since we targeted the intent of the credit, which is to provide visiting bike program. Okay, so this is one of my least photogenic slides. So this is the points. So on this slide, I've got these are the three categories you can target. You get 4-star, 5-star, and 6-star. We obviously get a 5-star build rating, which means you get between 60 and 74 points. The bar graph there, the dark green is the points we actually achieved in that category, and the light green is the points you could have achieved. And these are all the overall Green Star rating points, so everything's scaled. You don't have to think about which credits scale which way. So out of 105, essentially, because you can get 5 additional credits for innovation, you can see which points we got in each category. So you can see, for example, in transport, we get all 10 of the final rating points in transport, which is relatively simple to do in Wellington because we've got such good public transport. So essentially you target, for example, bicycles, bike parking, showering, that sort of thing to target all those credits, as well as having a small amount of interior parking. In other words, not having a lot of parking on that. So we got just under 70 points for the building in the final scheme of things. All right, so in that category down in the bottom with innovation, we targeted and achieved 3 innovation credits for that building. So the innovation in Green Star is essentially in 3 categories. The first category is essentially new stuff to New Zealand or new stuff for commercial buildings in New Zealand. The second category is essentially exceeding Green Star benchmarks. We can target any points in that category. And the last point is environmental impact, showing you've done good things for the environment or your pocketbook or both. So we targeted 2 credits in that first category. The first one was seismic in situ testing. So this is the first for New Zealand, where in a commercial building they actually took and there was a belief that the structure would perform and meet current earthquake codes. So as part of proving that, so the structural engineers could sign off on the dotted line and say we're all good, they actually cut part of the building free. So they cut a beam free of the concrete in the building with saws. Cut it completely free, chiseled off all the concrete, put hydraulic jacks on it and bent it to show it would meet the load rating. Yeah. And then you just go back and fix it. It's concrete and steel, just fix it. So by doing that, we didn't need to go back and do any additional strengthening. And that made the structural engineers confident enough to sign off on that. So it was Oricon. So Tony Holden's written a technical paper on that. That's available. It's been published in at least 1 journal, as well as a magazine article. So all the civil engineers are probably familiar with that. So that was the first in New Zealand. The other innovation we have for first in New Zealand was Temper Zone. So Temper Zone, in cooperation with Stout Street, essentially went off on their own and designed a multi-fan DC fan coil. So you have a single fan coil box with single hot and chilled water coils in it, with multiple fans. So you can have a 4-zone, for example, this is a 4-zone unit, so it's got 4 separate electrically commutated motors. So you can run different amount of hot or cold air to each of the 4 zones. And then there's a controller box that goes along with it, which connects to the VAS system. So this is similar to other systems built from overseas, but this is manufactured in New Zealand. So it's made locally, and the expertise is local. So if something goes wrong, you can call them up and they can show up instead of having to bring parts in from the UK. And the last thing, the last innovation credit was advanced temperature setback controls, which in this case we showed that we connected the temperature control in spaces. When it's unoccupied, it widens the HVAC setback bands. So if you have a space, let's say we're controlling this space to plus or minus a degree and a half. If you have a space that's unoccupied and the occupancy sensors notice that, they can, let's say, decide, well, we'll control that space to plus or minus 2.5 degrees or 3 degrees. It's quite simple to set that in the BAS, and that saves energy.